Hey guys, Siva here. I've been wanting to do a talk on WebSockets and WebSockets testing for a while now, and never had the opportunity, or was feeling lazy all along. Funnily, I'm on a road trip right now. We are driving from Oregon to California. So I thought, why not do a lightning talk? And the views are beautiful. I also want to record the views. So yeah, without further ado, let's get started. Give me 1 second, let me pull up the slides. Alright, so today the agenda is going to be making WebSockets automation great again. We have Alfred with us. I'll be sharing the slides later. I'm on slide 2 right now, just for reference. On slide 2 we have the agenda, which is going to be making WebSockets automation great again. And we have a picture of Alfred from Batman. I'm a big Batman fan, and Alfred is always on all my missions. So the mission for us today is to make WebSockets automation great again. Give me 1 second, technical difficulties. Alright, so let's move on to the first one. So WebSockets versus REST. All along, like, we've used REST-based systems. I'm sure anybody in the audience who's listening to
In a half mile, keep left to stay on I-5 South.
So you all truly know that this is from a road trip, right? So the Google message just adds flavor and color to the presentation, which is great. I've just muted that, so let's dive into it. So the slide number 3 on the presentation is WebSockets versus REST, and all of us here have used REST-based systems in one capacity or the other. I'm not going to make any assumptions, so I'll just quickly walk through the difference between REST and WebSockets. With REST, you have a typical client-server model. You make a request. The web framework you're using to make the connection, that can be your HTTP client in Python, Apache HTTP client in Java, a lot of other things, like any of the HTTP abstractions in Golang as well. So the point is, you make a connection to the remote server, and your connection kind of encapsulates all the information that the client is passing for making a successful request for the server. The server would then handle the call and look into what are the different contents of your incoming request, and then give the data back. So that is a typical client-server model that we've been using all along. With REST, we've used REST with XML, REST with JSON. A lot of different data exchange formats can be used with REST. Most popular are JSON and XML. Now, WebSockets, funnily enough, does start with REST. Not a controversial statement, let me clarify. So what typically happens in a WebSockets connection is the client establishes a TCP session with the server. The server would then respond saying, basically an ACK or an acknowledgement, and then the client sends what is called the upgrade header to the server, saying it wants to upgrade the connection from being a REST connection to a WebSockets connection, and then the channel becomes a duplay channel where the client and server can continue to talk without having to re-establish any of the sockets or connections of any sort. Alright, I'm going through some traffic right now, switching lanes. Alright, where were we? So WebSockets versus REST. So in WebSockets, like I said, the client sends a message, the server acts, acknowledges, saying it's received the initial message, and then the client sends what's called a upgrade header, and then the TCP connection becomes a duplay, and the data starts flowing back and forth. Now, you might have heard a pretty popular statement with respect to REST, saying REST is stateless. By that, what they typically mean is every time you make a REST-based web request, the request will have to contain all the information for the request will have to contain all the information for the client to to receive information or response from the server. By that I mean there is no the server cannot preserve any of the existing state or a marker to what data it is sent to the client. So it's typically the client making a request, server looks at that request and then responds back. So everything that's necessary for the successful request is contained in that round trip interaction that happens between the client and server. So that is REST, and that's why there's no state involved, as in the server does not keep a tab on the response that is sent to the client. If the client needs the same data again, it has to make a request again. If the client needs, let's say for pagination's sake, if the client needs the next set of data, the client would then refresh the request with the pagination parameters for the next page, and then it would send the data again. So that is REST that we've all used so far. REST with XML, REST with JSON, doesn't matter. That is REST technology. With WebSockets, I was saying, server would keep a tab. So initially when the connection is established, the server would then keep a tab on what is the info that it has just sent to the client, and that way in the do play channel, server can keep sending bursts of data. By that I mean, let's say you have a ticketing system, and as a client you're making a connection to the WebSockets API, and you want all the tickets for a specific account, tenant, whatever system that's being designed for the last 24 hours. And let's say you have more than 1,000 tickets, right? So in a REST model, you would make the initial request. If you have not specified anything about your page size or offset, you would get the first 100 tickets back, and then you would just cycle through all of the rest of the 900 tickets based on the subsequent requests that you would initiate from the client, and refreshing the pagination parameters. Now when it comes to WebSockets, for the same scenario, for the same workflow, the way it would typically happen is the client would make the initial connection. Getting some beautiful views here. I'm not sure what these mountains are. Sorry for the sidetrack. So in a WebSockets, what happens though is when the client makes the connection to the server, typically what happens there is the server sends the first burst of data as part of the response. And remember I said it's a do play channel, so once the initial socket is established, the client never maybe passes some kind of a keep alive messages, but then there's no subsequent session or a new request being sent unless one of two things happen. One, either the server says, hey, I've sent all the data, so it closes the connection, which means if the client wants any additional information, they will have to get that information again. Or the client can close the connection after it deems that it has received sufficient data, and then any new data transfer will have to happen over a separate WebSockets connection established. So real quick summary with respect to REST and WebSockets. REST is stateless, meaning every request coming from the client will have to contain all the information necessary for getting successful response from the server. WebSockets though is stateful, meaning after the initial connection, the server can keep tab of what data it has sent to the client, and then subsequently can refresh all the data that it keeps sending to the client. On to the next slide, which is how did I automate the WebSocket system I was working with. So not very long ago, the company I work for, they had a backend which switched from being JSON based REST API, REST microservice, onto GraphQL initially, because we couldn't scale for the load and the work and the usage scenarios that we had in mind. And then once we made the interim stop at GraphQL, we wanted to further make the system more performant, and what we decided was we were going to move into WebSockets. So the architect established a pattern which was GraphQL subscriptions over WebSockets. In terms of test automation, I've used a couple different frameworks in the past for WebSockets automation, but nothing with GraphQL subscriptions over WebSockets. So I had the task at hand. I think it was probably October of last year. The task was defined. So I started trying to see what was out there in terms of implementing a comprehensive solution for testing WebSockets. What ended up happening was concentrating on the road a bit. What happened was I started off with native GraphQL support in Python, which was good, but I still had to bake in the WebSockets aspect of it. So I had a ton of boilerplate. I had I would say version 0 of the automation solution, which I wrote using Python WebSockets and Python GraphQL. I want to say the library was GQL. So both were separate at that point in time, and I had to write a lot of glue code in using WebSockets to create the session management, and how I would leverage data objects within GraphQL for serializing and deserialization of the response. Things were okay. I got it working, but as they say, make it work, make it right, make it fast. I wanted to make it right and then make it fast. We have wonderful views here. I'm going to quickly show you all the picturesque route we are taking. Presentation. So like I was saying, I made it work, but I wanted to make it right and make it fast. Primarily my motivation, funnily enough, was that I had everything in a local GitHub project. I had not committed the code because I was not proud of it. There was a ton of boilerplate, and like I said, it was as though the things were put together by glue and not like a cohesive system. So I was trying to look for other options, and fortunately around December of last year, I think, is when I came across Python GQL, which is a library, Python GQL support for native support for WebSockets, meaning WebSockets interaction became first-class citizens in that framework. It was not REST only alone, and on top of that, they were able to do. They implemented very clean APIs for session management with WebSockets GraphQL, and also what's the word I'm looking for? GraphQL subscriptions. So basically, it was a off-the-shelf solution for GraphQL subscriptions over WebSockets. So made my life especially a lot easy when I had to come up with a solution. Just a bit of background here. So I've been an automation engineer for about 7-8 years now. Fortunately, the last few years, at least the last few jobs of mine, I've had the privilege of working on system architecture, both from an automation standpoint and also from a development standpoint. In this case, it was really exciting from a system architect perspective when I saw Python GQL give you an off-the-shelf solution, because one, it's tried and tested. It's got the support of the community, and two, have the backing of the community to keep changes, versions, and any new changes inside of the WebSockets protocol in and of itself. All that would be kept up to date, or at least that's the hope. So finally landed on Python GQL. So it helped you with. They have very clean APIs. That's probably the first one I look for, and their documentation is pretty watertight. I've used it for about almost 8 months now, and I really like the way the framework is put together. Their APIs are very, very clean, and they have solid documentation as well. So if you're looking for a off-the-shelf solution with for testing or developing automated systems against not only test automation, right? You could do a lot of management stuff, or even if you're in the business of collecting metrics and you need to interact with those WebSockets APIs and whatnot, I would highly recommend you check out Python GQL. It's got, like I said, GraphQL subscription support baked in, and it is built on top of Python WebSockets. So let me take that back. I think they support Python WebSockets via a driver. Not sure if it's like a native code base, but the point being, the integration is airtight. You can like scale your solutions really well. The setup is currently running in where I'm using it. It's running in a CI fashion, again using GitLab and GitLab runners. There's no reason why you cannot do the same in something like Kubernetes with like your kube pods and whatnot. So that is a solution, and that was the intent for this talk, is to raise awareness of, hey, there is this Python framework available out there, and anybody who would like to implement that or test it out, or have any kind of like difficulties trying to use it prime time for your production-based systems, hit me up on Twitter or LinkedIn, where I'll be sharing this content. And finally, I do have a question. So I end all my presentations with a joke. The joke for today, and by the way, shameless plug, there is hashtag Siva stand-up jokes that is available both on LinkedIn and Twitter. Do check it out. It's clean tech-related humor. You would not have you wouldn't have any issue in trying to see those comedy from, or read those comedy from your your work laptop or in front of your family or whatever. So yeah, do check that out. And for the question for today, before I wrap up the presentation, is why are WebSockets called the peeping Tom of communication protocols? I'll repeat that. Why are WebSockets called the peeping Tom of communication protocols? I'll give it a few seconds for you all to like think responses or think for answers. All right, we are passing something called a Sexton Mountain Pass. It's like a 69,000 elevation or 6,900 elevation. This is awesome. I'm so glad my wife gave me this idea of recording a talk, because like I said, I'm very lazy and I don't want to see. Oh my god, yeah, I am very lazy, and she just said, we have like a few hours drive to California, why don't you record a presentation? So as with everything, she's always right. I'm totally enjoying this. So finally wrapping it up, the question was, why is WebSockets called the peeping Tom of communication protocols? The answer is, if you are on a Duplay, it makes it very easy for you to peep on your neighbors. Do you get it? Alright guys, hopefully it was not a cringe comedy. Hopefully some of y'all enjoyed it, and I'm going to leave you with this amazing view of the mountains, and see y'all next time with another bite-sized video. Bye now.